Chapter 5, Section 8, Simplifying Radicals. A radical is simply just a square root symbol. So as we see here, this square root sign is a radical. So a radical is when you try to take the square root of something. In order to simplify radicals, we need to know what perfect squares are, because we are taking the square root of something. Here we see that we have a perfect square chart. We see that 1 squared is the same as 1. So if I were to take the square root of 1, that would be equal to the number 1. If I were to take the square root of 4, that would be equal to the number 2. If I were to take the square root of 9, that would be equal to the number 3. And so on and so forth. A perfect square is basically when we take the square root of something and you get a whole number out, so there are no decimals. When we talk about simplifying radicals, we need to find the perfect square of the number that is underneath the radical. So the number that is underneath the square root sign. We see here that the number underneath our radical is 144. Our first step is to look at our chart and see if this is a perfect square. If we look at it, we see that it is a perfect square, and it is 12. So, we will write that the square root of 144 is going to be equal to 12. Now, sometimes your square root is not a perfect square. So, if we look, we see that underneath our radical this time, we have the square root of 363. If we look at our chart, we see that there is no 363 because in between 324 and in between 361 and 400 would be 363. So this is not on our perfect square chart. So it is not a perfect square. Our goal now is to find the perfect square of 363. So we will utilize our square root chart. And we will go down the line and try to find a perfect square that can be divided by this number. So we'll start out with always our 2. So we would do 363 divided by 2 and try to see if we can get a whole number out. When we use our calculator, we can do 363 divided by 2. And we see that gives us a decimal. That's 181.5. So we know that 2 will not work. So we're going to erase 2. And I'm sorry, I made a typo here. We should be using the ones on the left-hand side. So we should have used 4 here. So we would do 363 divided by 4. Always use the numbers on the left-hand side. So you do 363 divided by 4. And we see that gives us 90.75. So that does not work. So we need to go ahead and find the next number. And we see the next number on our chart on the left-hand side is going to be 9. So we're going to do 363 divided by 9. And that gives us 40.333. That's still a decimal. So we know that perfect square does not work. So we're going to go to the next perfect square, which is 16. So we do 363 divided by 16. And that gives us still a decimal, 22.6875. So we have to keep continuing down our chart over and over again with all the numbers until we find a perfect square. If you were to keep going, you would get all the way down to the number 121. And once we went ahead and divided this by 121, we would see that 363 divided by 121 is the number 3. So that means when we divide by the perfect square of 121, we have 3 left. Or, in other cases, 363 is the same as 121 multiplied by the number 3. Now, part of that is a perfect square. That 121 is a perfect square. As we look at our perfect square sheet, we see that 121 is the same thing as the 11 squared. So what we can do is we can put the 11 on the outside, and then on the inside we leave our unperfect squared, which is 3. Because we see that in our chart, 3 is in between 1 and 4, and that is not a perfect square. And there is nothing that is a perfect square that can go into that number. Let's try another example. Here we see that we have 2 times the square root of 81. So we're going to go ahead and try to find the perfect square of what is underneath our radical. And underneath our radical, we see the square root of 81. We're going to look at our perfect square sheet, and we see that 81 is actually a perfect square. It is the same thing as 9. So we would say that the square root of 81 is the same thing as the number 9. And we're going to keep our 2 that was already on the outside. And since we're multiplying 2 in the square root of 81, you're going to be multiplying 2 and 9. Remember, 9 is replacing the square root of 81 because the square root of 81 is the same thing as 9. So we have 2 times 9, which gives us 18. Let's try another example. Here we have 3 and the square root of 75. We're going to again start with the number underneath the square root, and that will be 75. We're going to go ahead and find out what are a perfect square of 75, because if we look at our sheet, we see that 75 by itself is not a perfect square because it is in between 64 and 81. So it is not on the square root sheet. So we're going to first divide by 4. And when we do that, we see that we end up with a decimal out of 18.75, so that does not work. So we want to try the next number down, which is going to be 9. So we do 75 divided by 9. And when we do that, we get the decimal of 8.333. So 9 does not work. So we will erase our 9. And then now let's go ahead and try the next one, which would be 16. So we do 75 divided by 16. And we see that also does not work because we get 4.6875. So we're going to erase the 16. So then let's now try 25. And we see that 75 divided by 25 is going to give us 3. So that works because we still have 3 left. So then we see that 3 and the square root of 75 can be changed to 25 multiplied by 3. Now part of that is a perfect square, and that is the 25. That is the same as 5. So we can bring that 5 out. We can do 3 times 5 because the square root of 25 is the same as 5. And we can keep our radical 3 in the parentheses. This can now be simplified because we know that 3 times 5 is 15. And we can keep our radical 3 underneath the parentheses. Now we know that radical 3 cannot be simplified because it is in between 1 and 4. And there is no perfect square that would go into that. I want you to pause the video here and try these problems out on your own. Then I want you to press start and we will go through them together. Alright, now that you've paused the video and tried all 4 of these problems on your own, we're going to go through them together and see if your work was correct. Our first one here says the square root of 25. If we look at our perfect square sheet, we see that the square root of 25 is actually already a perfect square, and that is 15. So the answer that you should have gotten there was 15. If we now look at the blue problem, the square root of 98, if we look at our square root chart, we see that that is in between 81 and 100. So we have to figure out a perfect square that goes into this number. So we will start out with our number underneath the radical, which is 98. And we will first divide it by 4. So 98 divided by 4 would give us 24.5, so that does not work, so we erase the 4 underneath. We can then try 9. So we do 98 divided by 9, and that gives us 10.89, and that does not work because that is still a decimal. We can then try 16. So we do 98 divided by 16, and that gives us 6.125. That is still not going to work. We can then try 25. And when we do that, we see that we get 3.92, which still does not work. So then we try 36, which gives us 2.72, which still does not work. So then we decide to try 49. And when we try 49, we see that we get the whole number of 2 out. So that is perfect, because this equals 2. So the square root of 98 is the same thing as the square root of 2 times 49. And we know the square root of 49 is the same thing as 7. So we'll bring that 7 on the outside and keep that square root of 2 on the inside. So you should have got 7 square root of 2 there. Alright, let's go ahead and try the orange problem now. On the orange problem, we see that we already have a 7 on the outside, but on the inside, we have the square root of 80. If we look at our square root sheet, we see that the square root of 80 is not a perfect square, as it is in between the square root of 64 and the square root of 81. So we need to figure out what is a perfect square of 80. So we're going to do 80, and we're going to start out with 4. And when we do 80 divided by 4, we see that we get 20 out, which is perfect. And that will work. But if we were to keep going, we might find a larger perfect square, because 20 is such a large number. So let's go ahead and try to keep going with that and see if we can't find a bigger perfect square. So let's go ahead and try 9. And when you do 80 divided by 9, we see that that is not a perfect square. So we're going to erase that and keep going. So let's go ahead and try 16. So when we do 80 divided by 16, we see that also works. That gives us now 5 out. And 5 is a smaller number, and it is in between 4 and 9, and we know that none of those can go into 5. So we would go ahead and keep that as our answer. So this will be 16, and this is equal to 5. And so then our square root is the same as 16 times 5, and we know that the square root of 16 is the same as 4. And we can keep our radical 5. So 4 square root of 5. Now, I know some of you may have left it as when you divide it by 4. But remember, you always want to try to see if you can get a larger perfect square out, because we want the largest perfect square that we can possibly find. Let's go ahead and do another one. We're going to do 5 times the square root. Oh, sorry, I actually did not complete this problem. We forgot about this 7 on the outside. There's already a 7 there. So that will be the same thing as 7 times 4, because we are multiplying that radical. So that goes ahead and gives us a final answer of 28 square root of 5. Now let's look at the purple problem. We see that we have 5 square root of 36, so we want to first look at our perfect square, which is 36, and we see that that is already a perfect square, so we keep that on the outside. So we're going to go ahead and use that, like the same thing as 6. So we do 5 times 6, which gives us 30. Now let's talk about simplifying radical expressions that have letters. Here we see that we have t squared. With radical expressions that have letters, it's a lot simpler. We're just looking for even numbers. And in this instance, we see that we have a 2. So we would just take half of it. So half of 2 is going to be 1. So this simplified would just be t. Here we see that we have t to the 7th. Now this is not an even number. This is actually an odd number. But let's go ahead and change that to an even number. So if we were to find the closest even number to that that's smaller, that would be the same thing as t to the 6th. And we still have a t left, because t to the 6th and t to the 1 would make t to the 7th. You're just adding them together. So we know that t to the 6th, the square root of that would give us t to the 3rd. But yet we still have that t left underneath. Let's go ahead and do an example where we have both the letters and the numbers. So first we want to find the perfect square of our number. And we see that we have 25 underneath the radical. If we look at our square root sheet, we see that that is already a perfect square. So the square root of 25 is 5, so we're going to bring 5 to the outside. And then we have t to the 8th. And we know 8 is already going to be an even number, so we're just going to take half of that, and that'll give us t to the 4th. Now, if we look at our next example, we want to take the square root of 8t to the 6th. So first, let's take the square root of our number. We see that we have 8 here. And if we look at our perfect square sheet, we see that that is not an automatic perfect square. So we want to take 8 and we want to divide it by perfect squares. Now, if we start with the first one, we do 8 divided by 4, and that does give us 2. And so that is perfect. That is, we're going to go ahead and use 4 and 2. We would not be able to simplify that 2 any farther because we see that there is no numbers on the right-hand side that can simplify that. So this is 8 is going to be the same thing as 4 times 2. And our t to the 6 is going to stay as t to the 6. And we know that the perfect square of 4 is going to be 2. And the perfect square of t to the 6 is going to be t to the 3rd. And we keep our 2 underneath the radical. Now I want you to pause the video here and try to complete these all on your own. And then once you get done with all of them, I want you to start the video up and we will do the problems together. Alright, let's go ahead and try this first one out. Let's try the lime green one. So we're going to start with our number, which is 12t cubed. And we want to find a perfect square root of 12. Because we see that on our chart, it is not a perfect square root. It will be in between 9 and 16. So, we'll start out with 4. And we see that that does work. 12 divided by 4 is 3. And we would say that that would be our largest perfect square because 3 is going to be somewhere in between 1 and 4. And there is no other perfect squares that will go into the number 3. No matter what perfect square you try, you will never find a number that goes into 3. So, we're going to say that this 12 is the same thing as 2. And then the square root of 3. And then we have t cubed here. We want to find the smaller version of that, which is t squared and t. And the perfect square root of t squared is t. And then you still have that other t left on the inside. So this part, this t squared, was already a perfect square. So we brought that to the outside by taking half of it. And we left the other half, which was t, on the inside. Alright, let's go ahead and try the blue problem together. So in the blue problem, we see that we have 4m squared. So we're going to take the square root of that. And we already know that 4 is a perfect square. If we look at our perfect square sheet, it's right here. So we know that that is going to be 2. And we know that m squared is also a perfect square. We will just take half of that, so that would just be 2m. Alright, let's try our purple problem. In our purple problem, we see that we have 32 underneath our radical, so we want to find the perfect square of that, so we have 32. And we want to find a number that goes evenly into 32. If we try 4, we take 32 divided by 4, we end up with 8. And that is great. That is a whole number. But let's try to see if we can find a larger number that will go into that 32. So let's try out our next perfect square, which was 9. So if we did 32 divided by 9, we end up with a decimal of 3.56. So we know that that does not work. Let's try another perfect square. Let's try 16. So we see that 32 divided by 16 gives us 2. So that is perfect. So we will say this is just like 2. So we will take our square root of 16 on the outside, which would be 4. And then we would keep our square root of 2 on the inside, because that is what we have left. And we know the square root of 10 is just going to, t to the 10 is the same as t to the 5th. Because that would just be half of it, because t to the 10 is an even exponent. Alright, let's go ahead and try this orange problem together. We're going to first try to find the perfect square of 64, and we see that that is already on our chart. That is the same as 8. And then we have t to the 11th here. We want to find the smaller even number of that, and that will be t to the 10th. So then we have half t to the 10th with this t to the 5th left. But we still have one t left over, so we have to keep that underneath the radical. Alright, let's go ahead and talk about simplifying the radical expression when you're multiplying two of them together. So whenever you see that you have two radicals multiplied together, you're automatically just going to keep your radical. You're going to combine them together into one radical. And you will multiply the numbers underneath. So you have 10 and 2, and 10 times 2 gives you 20. So we have the square root of 20. And we're going to try to find the perfect square of 20. So we have 20 here. And we would take 20 and we would divide that by our first perfect square, which is 4. And then we have 5 left over. 5 is a small number, so we know that will work. So then we would take out our 4. So the square root of 4 we know is 2. That's a perfect square. And we'll keep our remainder, which was 5, underneath. Remember, when you're doing the perfect squares, the number that you're dividing by is always the number that's going to be moved to the outside. It would be whatever the perfect square is on your chart. So the perfect square of 4 is 2. Let's do an example with letters. So we have t cubed and t squared here. Now, when you're multiplying two exponents together, all you're doing is adding the numbers together. So you add exponents. Add exponents. Make sure you write that down somewhere. So in this instance, our exponents were 3 and 2. So we would add that together. So 3 plus 2. So that is the same thing as t to the 5th. Now we want to find the smaller even number of that, and that would be 4. So half of 4 is going to give us t squared. And we still have a t left over in our radical. Let's try another example here. So we're going to first multiply our two numbers together, and that will give us 48. And then we have a t squared here, but we don't have a t there, so we're just going to keep this as t squared, because 2 and 0 would make 2. So first we're going to try to find the perfect square of 48, and if we notice in our chart, it is not on there, as it will be in between 36 and 49. So we're going to start out with 48. And we're going to first divide it by 4, and we see that does give us a perfect square of 12. But that is a larger number, so let's try to see if we can find something smaller. So we are going to try our next perfect square, which is 9. And when you do 48 divided by 9, we see that it gives us 5.3, which is still really large. So we're going to go ahead and try another one. Let's go ahead and try 16. And when you do 48 divided by 16, that gives you 3, and that's a small number. So we will say that that works. So we're going to take our 16, which we know is a perfect square, which is the same as 4. We're going to put that on the outside. We're going to put underneath our square root our remainder, which was 3, on the inside. And the square root of t squared is going to be t. Let's go ahead and try another example together. So we need to go ahead and multiply these. So let's first multiply the outsides, because we see that we have the two outsides also multiplying by each other. So 2 times 3 is 6. And then underneath our radical, we see we have 8 and 2, and 8 times 2 is 16. And then we need to multiply our letters. And remember, we have a t squared, a t squared, and a t. And remember that t, when you don't see an exponent, you know that it is 1. So we would do 1 plus 2, because remember, you add exponents. So then that gives us t cubed. So first, we're going to take the square root of our number. And we see that it's on our perfect square sheet. So the perfect square of that is 4. So that would be 6 times 4, because we're bringing that 4 to the outside. And then we also want to find the square root of t cubed. And we know that t cubed is the same as t squared and t. So we're going to take that t squared out. Half of t squared is t. And then we're going to keep our other t that was left underneath. So first we need to figure out what is our 6 times 4. And we know that that is 24. And then we keep our t, square root of t. Let's go ahead and try another example here. We see that we have our 4 is not being multiplied by anything else on the outside. 4 is not multiplied by anything. We would just assume that's 1. So we're going to keep that 4 on the outside. And then on the inside we have a 6 and a 2, which gives us a square root of 12. And then we have to combine our letters, which is t and t cubed. So there's a 1 here when you don't see a number. So we have to add our exponents. So we have a 1 and a 3, which makes that t to the 4th. Now we need to first take the square root of our 12. So we need to figure out the perfect square of that. If we do 12 divided by 4, we see that we get 3 out. And that is a small number, so we can go ahead and take that 4 out. So we can do our 4 that was originally outside. And then we see that we have our 4, which came from our 12, and the square root of that from our square root chart is 2, so 4 times 2. And then on the inside, we still have our 3, because that was our remainder there. And then we have t to the 4th, and we need to take half of that to get t squared. Now we need to combine our 4 and our 2. We need to multiply those two together, and that gives us 8. And then we keep our t squared on the outside and our square root of 3 underneath. Now I want you to pause this video here and try to solve these problems on your own first. And then once you're done, I want you to start the video back up and we will go through them together. Alright, so we're going to go ahead and first we're going to solve the green one. So remember, since we are multiplying the radicals, we are multiplying the numbers underneath. So we have 15 times 6, which gives us a square root of 90. And if we go through our square root sheet, we are going to do our number underneath, which was 90, and we're going to first divide it by 4, because we know this is not a perfect square as it's between 81 and 100. So when we divide by 4, we get 22.5, which was a decimal, so we do not want to use that. So let's try dividing by 9, and when we do that, we get 10 out. Now, we may think that 10 is a large number, so we might want to try something bigger. So we can try 90 divided by 16, and we see that that gives us a decimal of 5.6, so that does not work. Let's try 90 divided by 25, and that gives us a decimal of 0.72. Now, since that decimal is already smaller than 1, we know that we cannot go any further to get any number that will go into 90 as a perfect square. So we're going to stick with our 9. And so then that gives us the square root of 9 is 3. So we're going to put our 3 on the outside. And then we'll put our remainder, which was 10, on the inside. Alright, let's go ahead and try the blue problem. So we have t to the 4th and t cubed. So remember, you go ahead and you combine those by adding them together, and that gives you t to the 7th. We want to take half of t to the 7th. Oh, sorry. We know that t to the 7th is not an even number, so we want to find the smaller even number, which is t to the 6th. And then we have t. The square root of t to the 6th is t cubed, because that is half of it, and we leave our remainder of t underneath. Now let's try the purple example together. So in the purple example, we're going to multiply them. We see we only have 2 on the outside, so we'll keep that 2 on the outside. And then we have 7 times 8, which gives us 56. And then t times t squared gives us t cubed. So we're going to try to find a number that can give us a perfect square of 56. So let's first try dividing by 4. So in our calculator, when we do 56 divided by 4, we see that that gives us 14, which is a large whole number. So we might want to try another one. So let's try 9. So let's try 56 divided by 9. And that doesn't work because that gives a decimal of 6.222. So let's try now 16. And that also doesn't work because it gives a decimal of 3.5. So then let's try 25. And that gives us a decimal of 2.24. So we're going to try another one. So we'll try 36. And when we do that, we get a decimal of 1.56. So let's try our next one, which will be 49. And that wouldn't work because it gives a decimal of 1.14. So let's try, we could not try 64. If we did, we would notice that that gives us a number that is smaller than 1. So we know that our largest number would be 4 that will go into this, that is a perfect square. Because 64 is larger than 56, so there's no way we can get a whole number out. So we're going to go ahead and take the square root of 4, which is 2. And so that'll give us 2 times 2, which gives us 4. And then on the inside, we have our remainder, which was 14. And the perfect square of t cubed, we know t cubed is the same as t squared in t. And t squared is the perfect square, so half of that would be t. And then on the inside, we have our remainder of t. So that will be 4t square root of 14t. Let's go ahead and try the orange problem together. So we're going to first multiply our outside, which was 21. 7 times 3 is 21. Then our inside is 3 times 12, which gives us 36. And then t times t cubed gives us t to the 4th. So 21 stays on the outside. And we know that 36 is a perfect square of 6, so we'll go ahead and bring that out. And t to the 4th is a perfect square of t squared, because it's just half of it. So we have to do our 21 times 6, which ends up giving us 126, and then we keep our t squared. Alright, we're going to try one other type of problem. This is when we have square roots in the denominator, because we notice here that our whole thing has a square root taken of it. So when you have a square root of the whole thing, you can separate it to the square root of the top, which is the square root of 6, to the square root of bottom, which is square root of 8. Now, you never, ever, ever want a square root in the bottom, so you have to get rid of it. The way that we can get rid of that square root of the bottom is multiplying by exactly what you have in the bottom. So we see that there's a square root of 8 in the bottom. So we multiply that by the square root of 8 again. Now the square root of 8 times 8 gives you 64. So this would now be the top, which is 6 times 8, which is 48. And the bottom, which is 8 times 8, which gives you square root of 64. Now we know the bottom is now a perfect square. So that is the same as 8 on the bottom, because the perfect square of 64 is 8. And for the top, we need to find a perfect square. We need to find a number for that. So we have 48, and we're going to first divide by 4, and we see that that gives us 12, which is a perfect square. But that is a large perfect square, so we want to try another number. So let's go ahead and try 9. And when you do that, you see that you get a decimal out. So then we're going to go ahead and try 16. And when you do 48 divided by 16, you see that you get 3, which is a smaller number, which is perfect. So we'll take our 16 here, and our remainder is 3. So that means that we have a remainder underneath of 3, but on the inside we have our 16, and the square root of that is 4. So 4 is square root of 3 over 8. Let's go ahead and try another example like that. Here we have 8 square root of 10. So remember, we're going to separate it. We take it to the square root of 8 over the square root of 10. Now we don't want a square root in the bottom, so we're just going to go ahead and take the square root of 10 and multiply the top and the bottom by the square root of 10 again. So you always have to multiply the top and the bottom when you multiply something. So this is going to go ahead and give us the square root of 80 on top, and then on the bottom, the square root of 100. Now we know the square root of 100 is a perfect square. It is the same as 10. So that will change to 10. And the square root of 80, if we go ahead and try to find the perfect square of that, we have 80. And we're going to divide that by 4, which gives us 20, which is a great number, but that is very large, so we're going to try to find another number. So let's go ahead and try 9, and when we do 9, we see that we get 8.89, which is a decimal, so that does not work. So let's go ahead and try 16. So when we do 80 divided by 16, we end up with 5, which is perfect. That is a smaller number. So we know that our perfect square goes on the outside, so the square root of 16 is the same as 4. And then on the inside, we're going to keep our square root of 5. So that's 4 square root of 5 over 10. Now let's just go ahead and summarize what we've learned so far. So, remember, we want to always use our perfect square sheet. And then we want to find out if it is a perfect square. If not, you have to divide by perfect square numbers. And your goal is to get a whole number answer out. Now, when you get that whole number answer, you want to try to get a number that is less than 10. If it is not less than 10, then keep trying higher numbers to see if you can find a larger perfect square. Sometimes you will, but sometimes you won't. The way that you know that you can stop is if the number that you are dividing by is larger than the number that you're trying to find a perfect square for. So, for instance, if you're trying to find a perfect square of 63, and you decide to try larger numbers, you found a number that worked, but you decide to try larger numbers. Once you get to the perfect square of 64, you want to stop, because the number on the bottom that you're dividing by, the 64 perfect square, is bigger than 63. So once it is larger, you want to stop, and you want to use the perfect square that you found in the beginning. So the largest perfect square that you found so far. So let's say the largest perfect square that you found so far, which is, this is not true, was 16. Then you would use that number. Now remember, when you're multiplying perfect squares, you just simply multiply them together. But when you multiply letters, you just add them together. And remember, the square root of a letter is just always going to be even. Whatever is the even number. All right, go ahead and try to start on your assignment. If you are confused, try to work through a few problems first and get your feet wet, and raise your hand on Class Kick while you need assistance.